Hello, this is William from Visual Components. In this video, I'm going to show you how to monitor the utilization of mobile robots. Utilization is a key performance indicator, or KPI. It can, for example, allow you to see how busy or idle a mobile robot is, and whether or not you need more robots or less to complete work in a production line. In the 3D world, I have a layout open, which you can find a link to in the video description. So open that layout. And we have one robot that can carry one item, and it's been assigned a task of picking apart from this station and bringing it over here and placing the part. So how can we track how busy that robot is? Well, we can use statistics, but more importantly, the states of the mobile robot. To access the statistics dashboard, go to the statistics group here on the ribbon, click this button. Here's the dashboard. Let's resize it a bit. And because we're only using one robot, let's choose this layout here, so you could double click it or click the create button here. And now we have to choose the chart type. Let's use the component state template chart here. Usually the templates require you to select a component first, which is why we get this prompt here. So let's select our robot. Gotcha. Then click component state, and now we have a chart. This chart uses interval-based data, so it's reported at each interval. By default, it's using the global sampling interval, which is defined here, and its default value is 60 seconds. So every 60 seconds, this chart will report its data. If we run the simulation, you can see it's still the same, so we have to wait after 60 seconds. So let's speed up our simulation. Here it gets 60 seconds, and we can see our robot is very busy. So it might be a bottleneck, and then after another 60 seconds, we get more data. At 2 minutes in the simulation, and it's still the same story. What I'm going to do is dock the statistics dashboard with the component properties panel. So I'll drag the panel to be at this center here using the docking manager. Let go, and now I can quickly see the statistics and the component properties. With our vehicle, let's see what happens when we create a delay after we feed a part. So I'll select the station here. Click this icon to access its notes, specifically its tasks. And I'll now add a delay here. So delay colon, let's use 10 seconds, and see if that affects how busy our vehicle is. So this is a good thing about using a simulation but also statistics. You can visually see and test different cases and also verify what's happening using the data. So we can see our statistics and also what's happening in the 3D world here. Run the simulation. It seems the robot is still pretty busy. Don't think the delay had any real effect, and yep, robot's still pretty busy. So let's reset and go back to those notes and change delay. Let's try 20 seconds, see if that has any impact. Might make the robot a bit less busy, but I don't foresee any significant change. So every 60 seconds you can see it's about busy 92% of the time and idle about 7%. Let's see what happens when we add another station that needs parts. So I will select this station, copy, paste, and let's move it over here. And run our simulation again. And what I foresee maybe is that because the travel time to and from these stations, the delay here probably isn't having that big of an impact. And after about 2 minutes or so, you can see, yep, we're still about 93%. So with this type of solution, one question I may ask is, do we need another robot to do this work? Because this one robot is pretty busy, and eventually it will need to recharge. Because we are using simulation, we can quickly test this. Let's just add another robot and see what happens to the state of that one robot. Let's reset, and in your eCatalog panel, go to the currently open Smart Collection or source. This displays items that are in the currently open layout, so we can quickly add a new robot. Let's go to its component properties. I'm going to change its color or material to be orange matte so I can differentiate these two robots visually. So orange matte, there we go. And by default, this generic AGV robot, it can carry 4 parts, whereas this one we have in our original layout can only carry 1. It is assigned a default task of AGV, which is the same task name that's being used at this station. So out of the box, both of these robots can work to pick and place the items. You can see, there they go. Now, because these robots are going to and from the same stations, there might be some block. They might block one another. We can visually see something like that happening here. So if we go back to our statistics, yep, we can see about 7% of the time the vehicles are blocked every 60 seconds. And our first robot is a lot less busy, but at different intervals it changes. Now, why do you think that happens? Why do you think the robot goes from being very busy to being very idle? Well, in an earlier video I talked a bit about the resource priority that you can use in the task controller here. So it can assign work to resources based on a priority. If we go to the component properties panel, you can see it's set to nearest, so the closest resource to doing a task will be assigned the work. What happens when we change this to be least utilized? Oh, these two robots should probably share the load. So this robot does a task, this one didn't do anything, so give it to work, and it's being given to work again. Let's go to our statistics, and this yellow robot, you can see it's kind of evened out now, so it's idle about 50% of the time, busy the rest of the time, but depending on the interval, it might need to catch up and do more work because of the priority we're using. It's also in a block state here too. Now, one thing we can't see here is the state of the other robots. So how can we add that to our layout here? It's easy. We're going to have to change the layout because we're only showing one chart here. And now let's pick this layout here that has two charts or two spaces on top of each other. So you can double click the item or click change here. This cell here is empty, so let's use a template of component state, but remember we have to select the component first. So this robot, and now we have the chart. There we go. If you want to focus on one specific chart in this layout during a simulation, you can of course use this expand or maximize button here. So we're looking at the second robot states here, but we can minimize it to see both and do the same for the other cell as well, or other grid. Let's run our simulation and see what happens. So we probably expect to see some blocked percentage most of the time, but both robots should more or less be, an equal load of how busy and idle they are. So after about 2 minutes, let's see what happens. The second robot here was blocked a bit. What about the first robot? So we're approaching 3 minutes, and yep, it was blocked a bit. Let's go back to our task controller and see how changing the resource priority will affect the statistics. So for least utilized, let's try cyclic. So it will assign the task to the first resource, then the next resource, and then the resource after that, and just repeat the cycle. So it'll kind of go in order. So first the yellow robot, now the orange one. Then the yellow, orange one, repeat the cycle, back and forth. And let's take a look at the data. And yep, you can see they've evened out pretty much. Looks good. So if you're happy with this solution, then hey, go ahead. But you might want to say, well, if I can save money and cost, maybe I only actually want to really need one robot that's very busy. And with that other resource priority, if we set it to be none, I think this will actually just assign it to one robot to do the work. And yep, it looks like this guy here, the yellow robot, is hogging all the work, and the orange one isn't doing anything. Okay, now with this statistics data, if you want to export it, you can do that. Just go to the statistics group here, and you have the option called export graph. You can export to an Excel file or to a CSV file just to have the raw data. You can also print the chart backstage to be print ready, so on an A4 size paper or however you want to. You can also print it to a PDF as well as a XPF file. I think you can choose that. Let's see. Yeah, you can export here to XPS. Now, what I recommend you do is try more cases with this layout and practice on your own. For example, what if you create another station that can be used to feed parts? Let's quickly see. So copy, paste, and because we copy and pasted, you can see it's using that task name that was already assigned to our mobile robots. With the task controller, let's set the resource priority back to cyclic. This way they're not blocking each other. So the one robot will be used for the task, and then the next robot will go to pick up the other part. Yeah, it looks okay right now. I don't think they might be blocked, but visually we might miss something, so let's check the data. And it seems every interval that they're pretty busy. And it seems this is a good type of solution here. Just waiting to see if they get blocked at all. Let's take a look at the first robot. It looks fine. If we're interested in a longer interval, what we can do, so instead of 60 seconds, let me get out my trusted calculator. So scientific. So 60 seconds, and let's see, there's 60 minutes in an hour, so times 60. So that's how many seconds every hour. Let's now see 8 hours. It's a lot of seconds, so let's copy this. So 28,800. Let's use that as our global sampling interval. We could, of course, select the chart itself and go to its properties and change its sampling interval. If it's -1, it's actually referring to the global sampling interval. And let's change it. Let's change the global one. That way we don't have to mess around with the chart's properties. Okay, so that's that. Let's go back to our statistics. And if we were to run our simulation like this, we really won't see any update happen here. So you could speed up your simulation to run really quickly. You could also use a warm-up time. So let's use 7 hours and 58 minutes. And we'll get to that point in the simulation pretty quickly. So I'll press play, and because of how fast I'm running the simulation, I'm also using virtual simulation mode instead of real time. We should get there probably maybe in a couple of minutes. It's going by an hour pretty quickly. There's 2 hours. And yep, we're now back in business. So we're about 8 hours and 8 minutes, and we can see our charts did update. So 96% of the time, this first robot was doing, it seems probably a little bit more work the other one. But it seems our second robot was blocked a bit. Usually when you have blocks, it's because they're maybe colliding or they're waiting somewhere that's blocking another vehicle. So one way to work around that is to add idle locations or places where the vehicles can wait. If we want, we can test that. Let's go to our eCatalog panel. Models by type. Scroll down and go to Works Pathfinding. And you can use this component for having your vehicles wait somewhere. You can use more than one if you want. By default, out of the box, these robots should work with this idle location filter. And if you actually select the robot and go to its properties, you can see it has this filter here for filtering out which idle location it can use. If it's empty, it will use any one that's available. Otherwise, the word that you have or string that you type in here has to match some part of the component's name, which it does. So by default, these robots have this for their idle position filter location or value. I'm actually going to reset this and change my simulation speed to be a lot higher. And let's see if we can get to 8 hours a lot faster. That's still taking a bit of time. So what I'm going to do is go to my cell graph panel, and for my resources, resource models, products, containers, mobile robots, I'll collapse all these things. Let's hide the works components for now, as well as our resources and resource models and our mobile robots. And let's actually just hide everything. and put our simulation on full blast. And what I'll also do is use this select all command here. A shortcut for that is the Control and A key. And oops, I actually can't select the visible components, sorry. So I'm gonna show everything again. And now use that shortcut. And you can see they have a simulation level of detailed by default. So what we'll do is we'll set this to be fast. And then we'll hide them using the cell graph panel. So we're hiding the visibility of each item in the categories here instead of directly changing the visible property. So now if I clear my selection, run the simulation, let's see what happens. So seems like it's a bit faster. And all we're doing is just waiting until we get to that state we want in our simulation of about 8 hours. And we're trying to get there as fast as possible. At least on my machine it's taking this long. I could of course hide this. So yeah, it seems a bit faster. And we're at 4 hours now. I'll try to think of another joke to tell you. Why did the mobile robot... What did one mobile robot say to another mobile robot? Domo arigato. No. I'm not good with jokes, sorry. So 5 hours. Let's get to that 8 hours. So in an 8-10 hour work shift, let's see what our robots did. And 6 hours. 7 hours. Let's get there. Once we get to about 7 hours, I'll start to try to slow down the simulation. And it's mostly taking this long because that Pathfinder is having to calculate the routes for the vehicles. Yep, slowing it down. Alright. Okay, so now we're about 8 hours and 8 minutes again. We can see the parts are flying around. That's because those are dynamic. They're not listed here. So let's go ahead and show everything again. We can quickly select everything using that hotkey, Control A. And let's change the simulation level back to detailed. And clear our selection. Here's our robots, but where's our data? Well, let's just go to our dashboard. You can see, here we go. Let's take a look at the first one, so I'll maximize it. About 96% of the time it was busy, and 3% idle. That's okay. Look at the other one. We can see, ooh, this one was blocked a bit. So about 4% of the time it was blocked. It may have been blocked by another vehicle. It may have had to wait somewhere. We don't know. So we could try to investigate that further at different time intervals. But visually we can see they're kind of bumping heads here. So we could try moving the stations or using different pathways to kind of limit where they go. Let's try that. So I'm going to reset. And let's reset our warm-up time as well. And what I'm hoping to see is when I'll get a block state for this resource. And we're not going to see that because I didn't change the global sampling interval here for the chart. So we'll still have to wait 8 hours. I don't want that. So let's change this back to be 60 seconds. And run our simulation. Okay, so it's not blocked yet. Just trying to see maybe within the first 10 minutes we can get an idea of what's happening. And yep, we got it there. So that was around 7 minutes, and it seems like they're getting blocked a bit here, going to and from. So you could try changing the grid size to avoid them being blocked, make it a bit larger. You could also use different pathways to kind of, instead of having this wide open area, you could strictly choose where the vehicles go. Another option to do, instead of directly assigning tasks to the robots, you could assign them a route to follow, and then based on where they go, they could do work along that route. But I'll end the video here. If you have any comments or questions, please feel free to visit our forum at forum.visualcomponents.com. And as always, I hope you have a wonderful day.